Assalamualaikum. Good morning.
Aku salam Datuk Malaysia.
Boleh dengar?
Boleh tu.
Apa dia echo? Ada echo. Hello? Boleh dengar?
Yes, Doctor.
Jangan buka dua speaker. So we move to our revision today, 2 hours. Turn to 21-22, semester 2. I invite Amira Suraya to read question 1, please. Amira Suraya, question 1. Mana budak tak datang? Nasrun, question 1, please.
Question 1. Consider the open loop pole zero map of the system as shown in the figure Q1. 1. Determine the open loop transfer function of the system. 2. Determine the j omega cross points of the arrival angles of the system. 3. Determine the range of gain K for underdamped response if the breakaway point is located at negative 0.7. 4. Illustrate the overall root locus of the system by including the obtained value B1, 2, 3.
Continue. B.
B. Unity feedback system is given in figure Q1. The system operates at 16% of overshoot with a natural frequency omega n of 9.64 radian per second. Determine the following. 1. The dominant pulse and the operating gain at this point.
Okay, thank you. Right. So, question 1A. So, you are given figure Q1A, no transfer function. Okay. So, you are required to determine the open loop transfer function. Okay. So, by looking at it, you have 3 open loop poles. Okay. And 2 open loop zeros. Okay. 1, 2, 3, 1, 2. Okay. So 0 minus 2 minus 6. Open loop zeros plus 2, 2 plus minus J2. Okay. So open loop transfer function. Okay. ES equal to K gain S minus 2 plus J2. S minus 2 minus J2. S plus 2. S plus 6. Okay. And the closed loop transfer function. is GS 1 plus GS. Okay, so it will be K S cubic. Okay. After simplifications. Okay. Determine the J omega crossing points and the arrival angle of the system. Okay. So in order to find the J omega crossing, okay, we have to do the Roth Lewis at this stage. So of root locus, apply Roth Lewis. Okay, where the characteristic equations. Okay. Oh, I'm sorry. This one is GS. Okay, I'm sorry. This one is GS. This one is correct. So we have to find the TS. Right? Okay, so the TS will be K S square minus 4S plus 8. And then S cubic plus 8S square plus 12S plus K S square minus 4S plus 8. Okay. So when you simplify, so you will get sorry, characteristic equation is the denominator of TS. So that's why S cubic K S square minus 4KS equal to 0. S cubic 8 plus K 12 minus 4K plus 8K equal to 0. Okay. So this is the characteristic equations and the considerations, okay, to be insert inside the root width. Okay. So we will up the root width. We insert the coefficients. Okay. So fill up this one. 96 plus 28K. 8K 0. Okay, so far okay? Hello guys, so far okay? Are you sleeping?
Okay, Prof.
Jangan tidur So this is the first column for stability. I told you before, the coefficients must greater than 0. Okay, greater than 0. Okay, this one greater than 0, greater than 0, then greater than 0. Okay, so 96, 28, 96 minus 28k minus 4k square. Okay, 8 plus k greater than 0. 96 plus 28k, 4k square greater than 0. So we have to simplify it. Okay, k square plus 7k, okay, minus 24 greater than 0. So you will get two value, which is k minus 2.5 and k plus 9.5 greater than 0. Okay, so k is greater than 2.5 is our target. Okay, then the second one is 8 plus k. Sorry. So use even equation from Roth-Lewis table. Okay, add s square, which is 8 plus k s square plus 8k go to 0. The k that we got is 2.5 from the Roth-Lewis, which is the critical gain. Okay, so insert inside here, then simplified, you will get s is equal to plus minus j 1.38. Okay, so this is the j omega crossing point of the root locus. Then the question asked you the arrival angle. Okay, arrival angle exists due to complex conjugate zeros at 2 plus minus j2. Okay, so to calculate arrival angle is the summation of poles, okay, minus summation angle of zeros plus 180 degrees. Okay, so you have to do some so what is theta A? So in order to calculate theta A, we have to somehow minus 6 to zeros. Okay, j2 minus j2. So We have to measure the angle towards the zeros here, guys. Okay. Macam tu. Which is this one is theta 1, theta 2, theta 3, theta 4. Okay, and theta A is located at these zeros on the positive sides. Okay, so theta arrival is theta 1 plus theta 2 plus theta 3 minus theta 4 plus 180 degrees, which is theta A. Tangent 2/8 plus arctangent 2/4 plus arctangent 2/2 minus 90 degrees plus 180 degrees. Okay, so theta A is 14 degrees, 26.57 degrees plus 45 degrees minus 90 degrees plus 180 degrees. So theta A is about 175.6 degrees. Okay. And theta arrival 2, the next conjugate is 175.6 degrees is equal to 184.4 degrees. This is the second arrival angle of the second zeros. This one is the first arrival angle of the first complex conjugate zeros. Right. So determine the range of gain K for the dam response if the breakaway point is located at minus 0.7. Okay. Breakaway point. So if we look here, the sketch of the given transfer function root locus is zero. Okay. 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 So given the breakaway point is minus 0.7. Okay. Breakaway, breakaway point given. So you are required to find the gain K at breakaway point. Okay. We already known this one. Okay. We already known that one is the J omega. So then 1.38. Okay, with the key of 2.5. Okay. So 1.38. Yeah. This one is plus J 1.38. And the gain key there is 2.35. Okay. So this one we know the point, which is minus 0.7, but we don't know the K. So how to calculate gain K over there? Theo, any idea how to find gain K at breakaway point? Theo, Ido. Anik, Aiman,
Yes.
how to find gain K at the minus 0.7? Nick,
I did.
S. Okay. Then you substitute with minus 0.7. So when you calculate, K will be 0.43 at breakaway point minus 0.7. Therefore, range of gain K at the dam region is 0.43, 1.38. Can? Hello? Hello? 1.38. Right. So this one is the under dam region. Okay. Okay. Anik, okay tak?
Okay dah.
Aku tanya kau jawapan pun kau tak tahu. Illustrate the overall locus by including obtained values. Okay, that's one you draw again. You draw back. Okay. Like I did in the question. Yeah. I draw like this. Okay, you have to draw like this. Some sketching. Okay, so we move to the second part, which is the this one. Okay, omega n. Okay, so what is the open loop transfer function? A fifth open loop transfer function. A fifth. Tidu. Kau datang Kau datang. Lim Jing Yi. Open loop transfer function.
S plus 3 over
S plus 3. Okay. Wait, S plus 3.
over S plus 10 times S square plus 3S plus 3.
Okay. Like this, Correct? Correct?
Yes.
Okay. And system is operated 60% overshoot. 60% overshoot. And apa lagi? Omega n 9.64. Okay. Hmm. The dominant poles and the operating gain at this point. So how to do it? We find the zeta first, okay? Given 16%, which will give you zeta, which is equal to by graph, by graph. Okay. After that, dominant pole formula. Magdi, dominant pole formula. Sleeping. Chu Jingwen.
No,
Uh,
I'm awake. but, but I don't know. I don't remember the formula.
okay, okay. Chu Jingwen.
Negative 4.856 plus J 8.32.
How you get that? Suddenly, how you get that? Is correct. This one,
Yeah.
So you insert the zeta and omega n. So you will get like a Chu answer. Okay. And what is the dominant pole and the operating gain at this point, or gain? So how to calculate gain? Okay, gain. Okay, tidur. Namanya budak tidur, Okay, so you replace S is equal to minus plus J inside here. So you will get K equal to 91.8. Okay. Peak time, settling time, steady state error for a unit step input. All right. Very easy. So the second part is the peak time. Just use pi, imaginary. Okay. Pi divided by 8.33. Settling time divided by real. 4 divided by real, which is real is 4.86. And the steady state error. So steady state error is 1 plus Kp due to system type 0. Can? Is it correct? Is it correct or not?
Yes.
So calculate the Kp. Limit S to 0, kgs. Okay. So K equal to 1. K equal to 1. K equal to ni. $91.8. Okay, the one that we got here. Yeah. So KP $91.8. What do you mean itu? S plus 3, S plus 10. So you replace, you will get 9.18. Steady state error is 10.98. Which is equal to 0.098. Okay. Validation of second order. Okay. So to validate for the second order, from the characteristic equation, S cubic wait, which is 1 plus K ds HS equal to 0. 1 plus K S plus 3 S plus 10 S square equal to 0. So K is 91.8. K is 91.8. So S cubic plus 13 S square plus 33S plus 30301 plus 91.8 equal to 0. Okay. Simplify, so you will get S cubic 13 S square plus 184.8 S plus 305.4 equal to 0. Okay, and then find the roots. Find the roots. Okay. So what is the roots? Help me. You, Gladys. Help me to find the roots. Gladys, are you there? You sleeping ah?
Hello.
Hello? Tak dengar.
Ah. Hello.
Find the roots.
Okay. Minus 1.86 minus 5.57 plus J 11.53 minus 5.57 minus J 11.53.
Correct. Is it same? Is it same?
Not same.
Why not same? This one, S cubic 13S square 184.8 S plus 305. Okay, you check again. Okay, and then verify. So we find the ratio of the what do you call that? The third pole. Sorry, yeah, the third pole minus 3.29 divided by 4.86. The real part of the dominant pole. Okay, this one is third pole. This one is real part dominant pole. So the ratio is 0.68, which is less than 5 times. So is it valid or not valid, Gladys?
Valid.
It is valid. Okay. Oh, this question quite long. And the controller design that could reduce or eliminate the steady state error as obtained in Q2B. Validate the new steady state error after the implementation of the proposed controller. So the last part is to propose PI controller. Amira Suraya, can you propose? The PI controller? Amira Suraya. Tak datang. Tak datang Anis, can you propose PI controller? Anis belum datang. Anis?
Datang
Okay,
tapi kejap tak tahu saya lupa.
okay. So that is our PI controller as Anis proposed. So G overall will be the G multiplied by GPI. Okay. Which is K S plus 0.01 okay, and then the steady state error. Okay, what is the steady state error? Is 1 over infinity, so it is 0. Okay, because when you attach system type 0 to the PI controller, automatically the system type will be increased from 0 to 1. Okay, and type 1, the steady state error is 0. We continue question number 2. I invite Chung Ka Jun. Chung
Yes, doctor.
Yeah, please. Can
没有，
you
它是 email，它是那个 page 那个 author application page。
Read. Hello.
okay, read.
Hello, doctor.
Yeah. Question 2, read.
2A.
Yeah, 2A and B.
A system can be described. A system can be described by a transfer function GS equal to 15 over S plus 1 times S plus 3 times S plus 6. In the case where the system must operate as a damping ratio theta equal to 0.591 and setting time Ts equal to 1.29 seconds, determine the positions of the system's dominant poles. Using a PD controller, design a response that meets the requirement of Q2B1. Continue.
Continue.
A unity feedback control system is given by in figure Q2B. Okay. From the unity feedback control in figure Q2B1 and the corresponding root locus in figure Q2B2, Seeger-Nicholas tuning method can be applied to design an optimized PID controller for the system. Utilizing R hash and the characteristic equation of the given system, determine the ultimate gain Ku and the ultimate frequency omega u as shown in for figure Q2B2. From B1, design the PID controller for the given system using Seeger-Nicholas tuning method. Determine the overall compensated transfer function. Use table A1, the Seeger-Nicholas in appendix.
Okay. Question 2. How to do it? So it is a system type 0. Okay. Determine the positions of the system dominant poles. Okay, I think this one similar like in the notes. So question 2. GS 15 over S plus 1, S plus 3, S plus 6. Okay. Damping ratio 0.591. Settling time in the case where the system must operate and settling time TS 1.29. Determine the position of the TS 1.29 second. Okay. Find the location of system dominant poles, not position, location. Okay, confusing. Location, eh? Okay. No root locus plot given. Okay. No root locus plot given. How to do it? No root locus plot given. So we
Doctor, can we use the formula TS is equal 4 over zeta omega n?
yeah, I'm thinking about it now. Thank you for the reminder. They are given open loop both load, sorry, transfer function, zeta and settling time. You determine the position. Okay. I think I got it. Okay, like this. The dominant pole is minus zeta omega n plus j omega n 1 minus zeta square. Okay. Ts is equal to 4 divided by zeta omega n. So this zeta omega n actually is real, 4 divided by real, okay, which is equal to 1.29 second. Okay, so omega n is equal to 4 divided by zeta multiplies 1.29. Okay, 4 divided by zeta is 0.591 multiply 1.29. Help me. Anis, help me. 4 divided by 0.591 multiplied 1.29.
5.24 Doctor. 5.24.
5.24. Magdi, correct? Sah? Magdi?
Yes.
Correct, So now, SD dominant pole, which is minus 0.591 multiplied by 5.24, okay, plus minus J omega n square root 1 minus zeta square. Help me. Lim Jing Yi, help me.
Negative 3.1. Then where? Brush 4.223.
Sorry?
4.23.
4.23. Okay. So this one is the real part. This one is the imaginary part. Okay. So this is the location of dominant pole. And the next question asks you to design the PD controller. So for that purpose, we have to draw. Okay. Minus 3.1. Let's say over here. Plus J 4.23. Can. Then the poles is here. So minus 3 minus 6. Can. Correct. Correct. And proposed 0, we put like that. Okay, at that point. Okay. Okay. And then you calculate theta 4. Okay. So what is the formula for to calculate theta 4? What is the formula to calculate theta 4? So you calculate theta 1 first. So theta 4 is somewhere theta 4. Theta 4 is the theta of the compensator, okay? So you have to calculate theta 4. Okay? Can you calculate? Or we have a break for 10 minutes first. Can? 10 minutes break. Is it okay? Hello?
Okay, doctor.
Yeah, 10 minutes.
Cause he can show you so much. I began to go again. There's a lot of work to be done. He gives you gold and he'll promise you the whole world will be yours. I just can't tell you I love you so. Even though my heart's I know I love it. Oh. The dirty games and the day of show. This is the world you know. Watching the stars satisfies my soul. Thinking of him makes me feel so cold. The fancy cars and the rest too. You just so fond of the man. Sometimes I wonder if you were there. Can you say it's good as mine?
Okay, we continue. So we have to search for the theta 1, theta 2, theta 3. So you need to help me since I don't bring my calculator. Okay, theta 1 is
Prof ada share screen ke?
oh sorry. Okay, Anis tolong saya kira ni. Okay, help me.
Lima puluh 55.57.
Next, theta 2.
Next 91.35.
Next,
116.4.
thank you. Okay, so 55.57 plus 91.35 minus 180 degrees. Chu Jingwen, theta 4, please.
The 83.32 degree.
Sorry,
83.32 degree.
83.32. Okay. So this is the dominant, okay? And the length is 4.23. And this is 3.1. And the consideration is x. Okay, this is minus ZC. Okay. So how to find x? Okay. Gladys, can you help me? Huh?
Yes.
This one, x, Gladys.
0.49.
0.5.
0.5.
0.5. Okay. Okay. So 0.5 meaning that ZC will be minus 3.6. Correct. Correct. ZC is minus 3.6. Yeah. Because the distance is 0.5. It's very close. So GPD is equal to K S plus 3.6. Your PD controller. Okay. Actually, this one is the KP. Okay, so overall will be GPD. $15. S plus 1. S plus 3. S plus 6. Okay. How to find KPD? How to find KPD? Li Jiaying. How to find KPD? KPD.
Yes, doctor.
How to find the gain of the PD controller? Can. Well, okay. So we replace with the dominant pole, which is here, minus 3.1423. Okay. where you get the APD. Then you insert inside here, multiply with 15, so you got overall. We move to the second part, which is the PID. PID component. Open loop transfer function. K S cubic plus 12s square plus 61s 150. Okay. So you are required to use Ziegler-Nichols tuning for the PID controller. So find the closed loop. Okay. And characteristic equations. S cubic 12s square 61s 150 equal to 0. Okay. And then you construct the truth table. One 12 150 plus K. Okay. So you need to fill up this. Okay. Continue. So I invite Shu Peiki. Can you help me on this part? Shu Peiki.
Yes, doctor. K minus 582 over 12.
Sorry.
K minus 582 over 12.
5, 8.
2 over 12.
3 minus
K minus.
K.
Yeah.
K minus
582 over 12.
overall,
Yeah, over 12.
0. And the last one?
The last one. 61. I think the above should have negative.
Above?
This one should have negative. Yeah.
Negative.
Yeah.
Negative bracket K minus 582.
Yeah.
Correct. The last one?
This one 61.
Oh, 61. Correct,
Yeah.
Okay, 61. Okay. So this one is greater than 0, greater than 0, greater than 0. This part need to be manipulated. Greater than 0. Okay. Okay. Greater than 582. Betul ke ni? Macam salah je. Is it correct? Because I don't have the answer. Is it correct? Show picking, is it correct? I think it's wrong.
K less than.
Huh?
I think should be less than.
Sorry?
I think it should be K less than 582.
How you get less than 582?
It's a negative K plus 582 greater than 0.
Again, eh?
Distribute the negative, doctor.
Yeah, okay, wait. I delete this one first. Okay. Negative K positive 582 greater than 0, correct? Correct?
Yes.
Okay, sorry. Thank you, Magdi. Okay. So therefore 0, K and 582 is the range of stability. And the K critical equal to KU equal to 582. Okay. So now is we want to find the omega U. So using even equation from Rothway's table at rho s square, which is 12 s square plus 150 plus K.
Sorry, Prof.
Yes?
I think the S power of 0 got something wrong.
Which one? This one.
Yeah, this one.
Mm.
S power of 0 is 150 plus K
150 plus K.
plus K, not 61.
Okay. 150 plus K. So is
Yeah.
it in fact the KU? Is it in fact the KU? No. Okay. Not in fact because we are using 582. Okay. So 582 over here is the KU. So 12 s square plus 150 plus 582 equal to 0. So what is S? What is S? Satya? What is S?
Yeah, 1.8.
7.8.
Yeah, plus minus.
So J
Changes
omega.
of that, yes.
So omega is equal to omega U 7.8. Okay. Omega U is 2 pi divided by TU. TU is 2 pi divided by omega U. 7.8. Satya again. TU.
0.806.
0.806.
806.
Mana Can Can. So you have to use the table of PID as attached in the exam questions to solve for Kp, which is 0.6 Ku. Ku is 582. What is Kp? Aiza, what is Kp? Aiza tak ada. Tak datang. Mak Ben Hua.
349.2.
And then Ti, Mak. Tu divided by 2. Tu is 0.81.
0.405.
0.405. Td, Mak again.
0.101.
101. Then Ki, Mak again. 349.2. 0.405. Okay, Mak.
862.22.
862.
0.22.
Then KPTD multiplied by TD.
35.27.
35.7. So that's why GPID. Okay. You insert inside plus 0. Oh, sorry. The standard of the PID is the standard of PID transfer functions. KD S square plus KP over KD, KI over KD over S. So you insert all the KD, KP, KI inside this, so you will get the PID controller tuned by the Legler-Nichols method. So we move to question number 3. Question number 3. Ang Jong-Ming. Ang Jong-Ming. Video. Mana Ang Jong Min? Ang Jong Min tidak. Irfan, question 3, please. Irfan, tidur lagi. Anik Aiman,
Yes.
read question number 3.
Question 3A. Describe two methods that can be used in plotting the dot plot. B. For the transfer function, Gs equals to K over S plus 4 squared. Determine the mathematical expression for magnitude and phase. B. 2. Determine the magnitude and phase of Gs at omega 20 radian per second and K equals to 5. Question 3C. A unity feedback system has the open loop dot plot as shown in figure Q3A and figure Q3B when K equals to 1. Determine the following. Type question 3C1. Type an order of the system if the system has only poles without zeros. Justify your answer. Uh, Question 3C2, gain margin and phase margin. Question 3C3, the damping ratio of the system. Based on the damping ratio obtained, identify the system category. Example, undamped system. 4, stability of the system. Justify your answer. 5, steady state error to a unit ramp input. 6, the new gain K if the gain margin is decreased by 50% from its original value.
Yo. Dah.
Dah.
Okay, this one. Okay, mathematical expressions, meaning that you have to somehow derive. Okay. S plus 40 square. K S plus 40. Kan? Correct? Is it correct? Okay. So now we find the magnitude first. Kan? Magnitude K. So dia punya magnitude dia adalah kan? Lim Lee Sin. Correct. Lim Lee Sin. Tak dengar.
Yes.
Correct.
Yes. Oh my God.
20 log will be 20 log K minus 20 log omega minus 20 log omega square plus 40 square minus 20 log omega square plus 40 square. So this is magnitude, magnitude in decibel. For the phase very easy. Constant 0 degrees, then 90 degrees, arctangent, omega divided by 40, arctangent, omega divided by 40. Very easy. Okay. Given K equal to 5. Okay, so for phase, we calculate phase first. 0 degrees, 90 degrees, 2. Arctangent, omega berapa? 20 20 divided by 40. Help me? Lim listen. Lim listen, help me.
Negative 143.13. 0.13.
You.
Mm.
Then for the magnitude in decibel, K 20 log 5 minus 20 log 20 minus 2, sorry, 20 log 20 square plus 40 square minus 20 log 20 square plus 40 square. Lim Ji, help me. Magnitude in decibel. Lim Ji.
I think it's negative 78.06
decibel. Okay. Okay, you can verify later on. Okay, so that is the way we calculate question 3B. Okay, question 2A, describe two methods that can be used in plotting boat float. Oh, sorry, I tertinggal this one. One is two methods that can be used in plotting boat float. Method 1 is using straight line approximation. Method 2 is using real point calculation, i.e. using computer lah. You have to use computer. Okay, question 3C. K equal to 1. Oh, plotting is given. Okay, plotting is given. Okay, this is the plotting. No transfer function given. Okay. What is the system type and order of the system? If the system has only poles without zeros. Macam mana tu? Okay. System type. Okay, you look at the plot. Tan Xing Yu.
Yes, doctor.
By looking at the magnitude plot, what is the system type?
First order.
Oh my God. I'm
First
asking you
order.
system type lah. System type, bukan system order.
Oh,
Ah,
type one, type one. Sorry.
mimpi ke? Ayo. System type 1. System order. Sekali lagi. Tan Xing Yu. System order. Order of system has only poles. Poles tu maknanya is more than one. Without zeros. The order might be three. Three,
Okay.
It's a 3. Because the slope is minus 20 dB per decade. Okay, what is the gain margin and phase margin? What is the gain margin and phase margin? This one I delete first. Liu Hongyao. Hidup. Tak datang. Jane Yang Wong. Tak datang. Yi Kun.
Yes, doctor.
What is the gain crossover frequency here?
Gain crossover frequency 0.8 5 or 9, 0.9.
Mimpi. Tengok betul-betul. See properly.
Oh, sorry. Or 0.0656.
0.05. Huh?
5.
3, 4, 5. 5,
Yeah.
Okay, omega phase crossover frequency.
What? 4.5?
4.5. Okay, sure. 4.5. Okay, 0.05. Okay, yeah. Okay. What is the phase margin? Chua? Chua?
Berapa? Oh,
Phase margin.
Uh, 9, 80, 85.
88. Okay. Again, gain margin. Chua?
Uh,
And
48.
4.5. 4.5.
Uh, 48.
40. 48.
48.
Okay. Thank you. I don't think it's 48. It's 50 probably. 50 lah. 50 yeah. 50. 50 decibel. Okay. Gain margin 50 decibel. Phase margin radian per second. Okay. Damping ratio of the system based on the system category. What is the damping ratio of the system? How to find the damping ratio from here? Any idea? Shupeki? How to find damping ratio?
I think use the phase margin then find from the graph.
Yeah. The phase margin is 88 degrees. Good. Phase margin 88 degrees, kan? Use graph. Can you use the graph? Zeta equal to? This graph, am I right? Please help. This graph. 88 degrees. 88 degrees somewhere here, guys. Alamak. Tak jumpa lah itu. Is it touch the curve?
Oh, no.
Huh? How come they give this such question? Siapa pun soalan ni. But the phase margin is correct kan? 88 degrees kan?
Yeah.
Huh? Okay. Not applicable. Okay. Just answer there, not applicable. Because you cannot see the graph from the given graph, 88 degrees. Ayo, siapa buat soalan ni? Right. And then the stability, stable, correct? Nice. Stable, stable. And number 5 is steady state error to a unit RAM input. So you have to use the ruler lah. Okay. This one. Okay. Use a ruler. This one is how many dB, guys? Uh, 4, 8, 12, 12, 12 decibel. So 1 decade, 20, 12, 8 lah, minus 8. Minus 8. Okay, 8 plus 12 is 20. So this is the minus 20 dB per decade line. So what you should do is you must take a ruler. Okay. And then cross at 0 dB somewhere. What is the kV over there? 0, 0.1, 0.2, 0.3, 0.1, 0.2, 0.3, 0.4. 0.4. Okay. From both. Equal to 20, 25. Okay. The new gain K, if the gain margin is decreased 50%. So the previous gain margin was 50 decibel. At 4.5 radian per second. Okay. Four point five. About here. Okay. So this is your 0 dB. Okay, so that is your gain margin there, which is 50 dB. So the new gain margin is decreased by 50%. 50 dB equal to 25 dB, correct? Lim Jing Yi, correct?
Yes.
Yes. So what should we do to the gain curve? Shift up or shift down? Lim Jing Yi. The gain curve should be shift up or shift down. The previous one, 50 decibel. The new one, 25 decibel. Let me draw for you so that you can see. We delete this one. Okay. Choose a blue color. Okay. So 25 decibel is about here. Okay. Can. So this is 25 dB. GM new. Okay. Oh, jauh pula perginya. Okay. Kita naikkan So you jadi macam itu. Okay. So we have to somehow shift up, correct? So shift up in the amount of 50 minus 25 decibel, which is mana dia pergi? Shift up gain curve in the amount of 50 decibel, the old gain margin, minus 25 decibel, the new gain margin. So it is 25 dB. So 20 log K, 25. K is equal to 20. 25 divided by 20. Lim Jing.
Uh, 17.78.
So this is the new gain K. Gain adjustment that you have to do. Okay, question number 5, we continue on Thursday. Thursday at 12 o'clock. Thank you very much for your listening. Assignment group, please. Are you ready? Assignment group. The rest can quit. Only for the assignment group. Hello? Assignment group.
Yes, doctor.
Group apa
Group 5.
10:30 kan?
Yeah.
Okay, are you ready now?
I think I'm okay, but I don't know.
So they still want 10:30. Okay, we come back again at 10:30. Okay?
Okay. Okay.
The same link, I think.
Okay.
Same link.
All right.
Thank you, Prof.